Let's begin. Today's June 2nd, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. We got criteria card 6, 9, 13, 17, 19, and 20, and uses the green verification cards. The code above is what you use to go into turingmachine.info to get the details on this puzzle. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, criteria card C. In the bottom row, we've got criteria card D, criteria card E, and criteria card F. Criteria card A will let us know something about the middle digit. We'll find out whether that value is either an even or an odd digit. Criteria card B will look at the 3-digit code and let us know how many of those are 3. Are there no 3s? Is there 1 3, 2, or potentially all of them are 3? Criteria card C will compare the middle and last digit, the square and circle, and will let us know whether the square digit should be less than circle, should they be equal to each other, or should square be greater than circle. Criteria card D will look at the 3-digit code and let us know how many of those are even digits. Are there no evens? Is there 1, 2, or potentially all 3 of them are even? Criteria card E will look at the first 2 digits, the triangle and square, and take their sum and compare it to the number 6. So should the sum be less than 6? Should the sum be equal to 6? Or should the sum be greater than 6? And finally, criteria card F again looks at the 3-digit code and what will let us know something about the structure of it. Should there be no repetitions, or in other words, should they all be unique, as in the example 125? Should there be a double or repeating digit, as in the example 112? Or potentially, could it be a single digit repeated 3 times, as in the example 222? Remember, our objective is to find this unique 3-digit code that abides by all the criteria that we've just discussed. And we're going to begin with the proposal of 314. So the first thing I want to test is criteria card A. I want to know that middle digit is either an even or an odd. Okay, so the Turing machine responds that it does not approve of my value, and notice I do have an odd 1. So what the Turing machine is telling me is that indeed square should be an even digit. So let me put that in my notes in section A. So square is an even digit, and since it is even, that means I can cross out all of the odds. So I'm going to cross out 1, 3, and 5. Okay, since I do know that's even, notice I do have this criteria card D that'll let us know how many evens there are. So let me go ahead and test criteria card D. Okay, so the Turing machine does not approve of the proposal. So notice I've got in my code 314, I've got 2 odds to 1 even. So it does not approve of there being a single even. Of course, there can't be no even since we've confirmed that square is even. So that means that either there are 2 evens or 3 evens. So let me put that in my notes in section D. There are either 2 or 3 even digits. Okay, so that doesn't really allow me to, cancel anything for square or circle since we still don't know anything. So let's go and, criteria card F will let us know whether they're all unique or there's a double or triple. So let's test criteria card F. Okay, so the Turing machine approves of the proposal 314, notice for this criteria, what's relevant is that they're all unique. They're all distinct. 314, there's no repeating digit. So that's what I'm going to put down in my notes for criteria card F, that there are no repetitions. So let's see, if there are no repetitions, if they're all unique, then that must mean that there has to be only 2 even digits. The only way I could have 3 even digits and have no repetitions is if I was allowed an additional distinct even, like say a 6 or an 8, but that does not exist. So that's very interesting, the combination of cards where we can now deduce that they are 2, 4, and an odd. So it's very interesting how, again, this combination of cards and the responses led us to have additional information that the code must have a 2, a 4, and a single odd. Well, that does it for this turn. We've already done our 3 Turing tests. Now we're going into the phase where we have to construct our next proposal. So let's take a look at what we have not verified or we have not tested. So we haven't tested B, which tells us the number of 3s. So what's interesting is, since I know there's an odd, either the 3 is there or it's not. So there can't be 2 or 3 odds, since we've already sort of confirmed that there are 2 evens. And let me go ahead and update my notes. I should have updated my notes here stating that there are 2 even digits. So yeah, there are 2 even digits. They are 2 and 4 and an odd. Okay, so and so what else have we not tested? We didn't test B. Oh, comparing square to circle, and finally the sum of the first 2 digits. Well, since I do have the 2 and the 4, if we take a look at criteria card E, we could have 2 and 4 in some order for triangle and square. So that would give us a 6 in some order, and that would force circle to be an odd. And potentially criteria card C could force the circle to be 1, 3, or 5. So depending on what square would be, 2 or 4, we could force, perhaps there is no 3, and it would force perhaps the circle to be 1, where square is greater than circle, or potentially if square is 4 and square is less than circle, it would force the circle to be 5. But if the sum is 6, meaning it's at some sort of order of 2 and 4, I don't see anything in the other criteria cards that would tell us definitively whether triangle is 2 and square 4, or vice versa, where triangle is 4 and square is 2. I don't see anything that would order it and then force circle to be the odd. So I think I believe then that circle has to be the other even. That must be the case. Okay, so that's a very interesting conclusion. So where could I put that in my notes? I'll just put here, we already know that square is even, so I'm deducing that circle has to be even. So not triangle, because there's no ordering there. So yeah, so I'm going to put circle is even. Okay. All right, so let me actually update my notes here and cross out the 1, the 3, and the 5. And so, yeah, square and circle are even. And of course, then criteria card C will let us know in what order the 2 and the 4 will fit in. Okay, so how does that now affect triangle? Well, we do have a sum, and I guess potentially you have so many options of there. So okay, so we know that it can't be equal to 6, because again, we kind of in our thought experiment, we were able to eliminate the possibility of equaling 6. So that means that it's either less than 6 or greater than 6. But there are just too many possibilities. 1 added to 2 and 4 are all less than 6. Oh, and I guess I should then cross out 2 and 4 for triangle, since I'm then saying that it should be odd. And remember, we do have this criteria card B that'll let us know whether there should be a 3 or there shouldn't be a 3. So, and 3, 2 is also less than 6. And we also have 3 and 4, and 5 and 4, and 2 and 5 and 2 that'll all be greater than 6. So it seems like it's a 50-50. So I'm just gonna test, let's just say that there is a 3, and again, the ordering of square and circle. So I'll say that it is greater than 6 and say it's 3, 4, 2. So let's go ahead and test 3, 4, 2. Okay. So since we do know that criteria card C will order our evens, so let's go ahead and test criteria card C. Okay, so the Turing machine responds that it does not approve of how I've ordered square and circle. So notice that my square is greater than circle. So indeed then square has to be less than circle. We already concluded that it's not equal since they're distinct. So I'm going to put in my notes for criteria card C that square has to be less than circle. So let's go ahead and do that. That was criteria card C. So square should be less than circle. And since we know that they're both even, well then obviously square must be 2 and circle must be 4. So let me go ahead and cross out the 4. And for circle, let me cross out the 2. So we know then that square is 2, circle is 4. And so let's take a look. So I said 3, 4 greater. So the sum of 7 is greater than 6. Does that still hold, or can I deduce that I got it wrong? So I've got 1 and 2. So the only sum that is greater would be 5 to 4. So it could be that the sum is greater, but there is no 3. So that, can I deduce that? So 1, 2, 4 has a sum that's less than 6. 3, 2, 4 has a sum that's less than 6. Yeah, I think I still need to test because, again, potentially the sum could still be greater than 6. And if I just test that, then I can deduce that there is no 3. So yeah, let me go ahead and test the sum. So that's criteria card E. Okay, so it does not approve of my sum being greater than 6. 3 and 4 is greater than 6, so it does not approve of that. We've already concluded it's not equal to 6. So that means that triangle and square have to add up to be less than 6. So let me put that in my notes. So triangle plus square is less than 6. So let's see, since I do have, okay, so since it's less than 6, it can't be a 5. Triangle cannot be a 5. And so I am left with the possibility, yeah, both 1 plus 2 and 3 plus 2 are less than 6. And I do still have that criteria card B that'll let me know, is there a 3 or not? And there's no way to deduce that. So yes, let me go ahead and test criteria card B. Okay, so it does not approve of there being a 3. So in my code I've got 3, 4, 2. It does not approve of that. So that means that there is no 3. Is no 3-digit. And at this point, well, there's only one 3, and so it gets canceled. So I'm going to cross it out. And so that means that my solution should be 1, 2, 4. So 1, 2, 4. Okay, so based on the notes, yes, the middle digit is even. There is no 3. The middle is less than the third digit. Yeah, 2 is less than 4. In our deduction and conclusions, we have to have a 2, 4 and an odd. Circle is also even. There is no 3, and since the sum has to be less than 6, obviously it's not 5, it must be a 1, and they are unique. Okay, so it looks like, yeah, we've got a winning solution, but let's go ahead and verify. And again, that was 1, 2, 4, 1, 2, 4. So 1, 2, 4, let's verify. Okay, so yeah, we got it. But again, we have to test, did we beat the Turing machine or not? Notice that we did do it in 6 tests. Well, there are 6 criteria cards, so I feel confident. So in the first turn, we tested A, D, F, and F was the only correct one. And then in the second turn, we tested the remaining cards. So A, D, F in the first turn. A, D, F. And in the second turn, we tested everything else. and everything else was incorrect. So let's go ahead and, oh wow. So we did it in six questions. The Turing machine actually had to do it in 8. That's pretty astounding. But we did come up with several good, deductions. We had these aha moments. So that was great. And notice we even got, 5 out of 6 were, we had X's. But again, just because you get an X, that is not a bad thing. It just lets you know that that particular setup or whatever the criteria is, it just eliminates it. You eliminate it from your next proposal or your thinking on how to construct the next proposal. And so, we take all this information, as long as we don't commit the same mistake twice, then it's okay to get X's. Well, this was, I think, a great success. I hope you enjoyed this puzzle. If you did, please do like, give it a thumbs up. If you don't want to miss the next video, please do hit subscribe, and you'll be notified for the next one. Well, that does it for today. Thank you. Have a great one.